Hello guys, this is Luis. So in the previous video we talked about DNS and the general concept of DNS. We discussed DNS queries. That was the last thing that we discussed, and then in this video we are going to talk about authoritative servers. Then we'll talk about forwarders. Then we'll look at the DNS zones. Now, when it comes to DNS, for every domain there is a server that is designated as the main DNS server of that domain. Now, this server is what is referred to as the authoritative server. This server contains every information about every single device on that domain. For that matter, when you deserve or request for any resolution about that domain, this server is the server that is in charge of the domain, and so it can resolve that information for you. So this server is the primary source of information for that domain, called the authoritative server. Every information you need about the domain, this server can get it for you. Then the non-authoritative server, on the other hand, relies on another server to be able to resolve any information about any domain for you. So in this case, this server does not contain the primary information. The server only knows the servers that can resolve those names. So when you type a domain name, a non-authoritative server will say that I don't know this name, but then I know the server that is in charge of this name. So let me forward the query to that server for that server to resolve the information for us. For most of these things to happen, we configure what we call forwarders. Now, a forwarder is any DNS server that you configure on your DNS server, such that if any query is not contained in your DNS server's database, then it needs to move or forward that information to another DNS server. Such a DNS server is what we call a forwarder. We have two types of forwarders. We have the standard, and then we have the conditional forwarder. Now, the standard forwarders are generic, which means that any name at all that you wish to resolve automatically, that is not in your DNS database, will automatically be forwarded to such a DNS server. So, for example, your DNS server by default is only going to contain the names of the servers that are in your domain, the names of the servers and the clients and computers that are in your domain. Now, when you want to resolve any name that is outside your domain, then automatically when you configure a standard forwarder, anything your DNS server doesn't know will be forwarded to such a server. So for example, I want to go to www.google.com. Now, my server is not authoritative for google.com, but because I have created a forwarder, then the information will be forwarded to the other server to resolve that name for me. Then we have the conditional forwarder. Now, conditional forwarders work this way. A certain condition needs to be met. Unlike the standard, which forwards any name at all to that particular server, with the conditional forwarder, you set a condition that whenever a query is made and then the query conforms to a particular name, then this query should be forwarded to a particular DNS server. So for example, I can decide that every DNS request should be forwarded to a particular server. But when a particular name, like let's say market.com, is requested, then it should be forwarded to a particular server. Then means that when someone queries the server and then it meets market.com, it's not going to forward it to the general forwarder, it's going to be forwarded to the server that has been designated to resolve the market.com name. And one thing that DNS servers do is what we call caching. Most of the time they don't know all the names. Sometimes they will need to, because of forwarders, they will need to request the information from another server. Now, when this is done, what the DNS server does is, okay, fine, I am not going to always go and request for this name. So when I ask for the first time, I'm going to keep it in memory. The memory is what is referred to as a cache. So whenever the DNS server requests for name resolution from another server, it keeps it in memory that, okay, fine, I'm going to keep this name in memory. So the next time someone queries me, I am not going to forward this information to the other server because I have the IP address of this domain in memory now, so I can just keep it. Now, both DNS servers and DNS clients keep what we call cache. So sometimes when you're on your client system, when the network is bad and you try resolving a name and then it's not able to resolve for the first time, at times you will try and try and try, it will not resolve. When this becomes the issue, you will need to clear the DNS cache on the client. Now, to do this, you will use the command ipconfig space / DNS. So when you hit this, it will tell you that what it successfully flashed the DNS resolver. This clears the DNS cache so that your client forgets any name it has resolved, and so that any name that you try resolving this time will be forwarded to a DNS server. Then we have the DNS zones. The DNS zones. Now, DNS name systems allows a DNS namespace to be divided into zones, which stores name information about one or more DNS domains. So a zone represents the domain for which a DNS server is responsible or authoritative for. Now, understanding the difference between zones and then domains. A zone starts as a storage database for a single DNS domain name. If other domains are added below the name used to create the zone, these domains can either be part of the same zone or belong to another zone. Once a subdomain is added, it can be either managed and included as part of the original zone records. So at the end of the day, what's happening is every domain has a zone. Now there are so many types of zones. We have the primary zone, we have the secondary zone, and then we have the stub zone. There are others like forward lookup zone and then reverse lookup zone, but then they are not classified as part of the zones. Let me talk about forward lookup zone and then reverse lookup zones first before we talk about the primary zone, secondary zone, and then the stub zone. Now the forward lookup zone contains record or informations that allows you to resolve a domain name into an IP address. And then the reverse lookup zone contains information that allows you to resolve IP address to domain names. So this time around, you use the name, the IP to find the name, whereas in the forward lookup zone, you use the name to find the IP. Now, the primary zone or the primary DNS server is the server that hosts the primary information about that domain. It stores the master copy of the DNS zone or the DNS records. So at the end of the day, this server generates or builds its own database, whereas the secondary zone pulls its database from the primary zone. So before there can be a secondary zone, there first needs to be a master server that hosts the primary zone. Then the secondary zone makes a copy of the primary zone. DNS server must have network access to the remote DNS server that supplies this server with updated information. So at the end of the day, these two servers must be in sync one way or the other, so that anytime there is any information that needs to be updated from the primary to the secondary, it can be done easily. Then there is the other zone called the stub zone. Now, when a zone that this server hosts is a stub zone, then this server is a source only for information about the authoritative name servers for this zone. So what this means is that, let's take for example, one organization has established a trust relationship with another organization. So we decide that we want our server to be able to resolve names from the other domain. Then we will create a stub zone. Now this stub zone is going to contain information about the DNS servers that are in the organization that I have established a trust relationship for. So at the end of the day, whenever my server receives any information about this new domain that we have established the trust for, it quickly forwards the information to those DNS servers. So the stub zone contains information about other name servers. So thank you for watching this video. In the next video, which is part 3 and the final part of the DNS, we'll talk about the DNS resource records, and then we will take a look at how DNS actually works in the server. Thank you.